side included between JLK, here's JLK, this angle right here, and LKJ, LKJ is this angle right here. The side in between those two angles is side LK. Okay, pause the video and see if you can get number 6, the side included between EDF and FED. Okay, the side included between angle EDF, which is here, and FED, which is here, is side ED. Okay, so getting back to congruent triangles, triangles that have the same size and shape. Instead of measuring all the sides and all the angles to see if they're congruent, we have what are called congruency shortcuts. The first one is the SSS, the side-side-side congruence postulate. And it says that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then we know the triangles are congruent. So you'll see something like this: MN congruent to QR, MP congruent to QS, and NP congruent to RS. So you have 3 sides in one triangle congruent to 3 sides in the other. The side angle side postulate says that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the triangles are congruent. So let's say we have side QP marked congruent to WX and side PS marked congruent to WY, and the included angle, the angle in between the 2 sides, is marked. So it would have to be angle P and angle W. Then we can say by side angle side that these 2 triangles are congruent. Okay, so using those 2 congruency shortcuts, let's see if we can find those in the following triangles. And if so, we're going to write a congruency statement. So the first one, we have side and side. We have an angle D and angle G marked congruent, and we have DE marked congruent to HG. And both of them have a side, an included angle in between the other side. A side, an included angle in between the other side. So the reason that these 2 triangles are going to be congruent is the SAS postulate. And the congruency statement, remember your congruency statement has to be exactly the order of the congruent angles and sides. So angle C goes in order of C to D to E. So C to D has 1 hash mark, a right angle, and then to 2 hash marks. So we have to go in the same order with our second set of congruency. 1 hash mark, the right angle, to 2 hash marks. So it has to be F to G to H. Okay, number 8. All we have marked is one side, and then the second side. We don't have a third side marked, and we don't have a reason to mark any of the angles. So these triangles are not congruent because there's no theorem or postulate to prove that they are. Okay, number 9, I want you to try on your own by marking the picture by your shared sides and your parallel line angles, and then see if it follows either the side angle side or side 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 postulate. Okay, you should have CBA in that exact order and side angle side. First thing we mark is side AC congruent to side AC, and then at the parallel line angle relationship gives us angle A congruent to angle C because of our alternate interior angles. So in this first triangle we have a side, an angle in between, and a side. And then in BCA we have the side, an angle in between, and a side. So it's side angle side. Okay, pause the video and try number 10. And you should have gotten triangle LMN congruent to triangle LPN in that exact order. And the first thing you mark on this picture is side LN congruent to side LN. And the congruency statement, L to M to N, L to M to N goes 1 hash mark to 2 hash mark to 3 hash mark. So when we make our second set of the congruency statement, we have to go 1 hash mark to 2 hash mark to 3 hash mark. So it has to be L to P to N. And 3 sides in one triangle are congruent to 3 sides in the other. That's the side-side-side theorem.